Let's now convert backwards from exponential form to polar and then rectangular form as well. So the angle of 3.84. So theta is equal to 3.84 radians. So to get that into degrees, you have to multiply by 180 degrees over pi radians. And when you do that, you find out that this is a 220 degree angle. So in polar form, this is written as 2.5, and I'm going to write this out longhand, times the cosine of 220 degrees plus j times the sine of 220 degrees. So I'm just going to come on over here and say that this is polar form. I wrote it out longhand so that now you could take, and I have forgotten to do this in advance, so I'm going to do it right now. You could take 2.5 times the cosine of 220, and when you do that, you get a negative 1.92. That's the real part of this complex number. Now would you take 2.5 times the sine of 220, and when you do that, you get a negative 1.61j. This is the rectangular form of the given complex number. Now remember, 220 degrees is in the third quadrant. So we should expect our x and our y values to be both a negative and a negative to get to that ordered pair. Very good. You go ahead now and do the next problem, then come back and see my answers. So theta was a negative 1.2 degrees. You can leave it negative if you'd like, and if you do that, when you multiply by pi over 180 degrees, you get a negative 68.8 degrees. You could also then take 360 and subtract the 68.8, because remember 68.8 is this way for a negative 68.8. So the positive version would be this one. So it'd be 360 minus the 68. So another way to write this answer is 291.2 degrees. I find it nicer to do that. I don't know why. And so in polar form, 5.83, I'm going to write it out longhand just to accentuate, times the cosine of 291.2 plus j times the sine of 291.2 degrees. Again, remember this is polar. And then to get this into rectangular form, you'll have to take 5.83 times the cosine of 291 and 5.83 times the sine of 291 degrees is in the the fourth quadrant. So we should expect our x value to be a positive, and we should expect our y value to be negative for this to be in the fourth quadrant. Again, this is our rectangular form. I will be asking you a problem to take it from exponential to polar to rectangular, and I will be asking you to go in the other direction as well. Finally, let's just do a few problems where we have to take a complex number in exponential form and raise it to a power, and then multiply a couple. But when doing these, I just want you to know that they just behave like, I don't know why I picked a 3 here, but they just behave like an algebra expression. So a monomial cubed means to take the 2 and cube it, and then to take the x cubed, take that 3 and multiply it by that 3 to get x to the 9th. 2 cubed is 8. X to the 9th is the answer to this algebraic problem. So to do this in exponential form, we're going to take 2.35 and we're going to raise it to the third power, and then we're going to take the 1.46j and we're going to multiply it by 3. So again, this 3 got multiplied by 3. 2.35 to the third power is 12.98. 1.46 times 3 is 4.38j. Here this is in exponential form. Would you go ahead and take a minute now, and would you turn this into polar by converting this angle to degrees, and then rectangular? My answers have just been added to the screen. So the 4.31 radians converted to 251 degrees. So here is my answer in polar form. Then when I took 12.98 times the cosine of 251, I got the real part of the rectangular form. And then 12.98 times the sine of 251, and I got the imaginary part of the complex number. in rectangular form. So we performed the indicated operations and we expressed our results in rectangular and polar form. Let's do the next one. So the next one says to multiply these two. So let's just say you had 2a to the 4th power and you wanted to multiply it by 3a to the 5th power. Well, to multiply those two monomials, you'd multiply 2 times 3 and get 6. And because their bases are both alike, a to the 4th times a to the 5th is a to the 9th, because you would add their exponents. So in doing this problem, we're going to take 7.2 times 4.1 and get a little bit more than 28. I would guess 29-ish. And then we're going to take the exponents, the 5.13j, and we're going to add the 2.78j together. These two numbers multiply together to be 29.52. These two exponents add together to be 7.91j. I decided to reduce 7.91, so I took on my calculator 7.91 and subtracted 2 pi, because there's 2 pi radians in a full circle. By subtracting 2 pi, you're subtracting the exact full circle, and when I did that, I got 1.63. So I wrote this angle right here as 1.63j, therefore it's already reduced. Lastly, would you please take the angle of 1.63 radians and convert it to degrees and give me the polar form? And then from that form, would you give me the rectangular form? I'll do that as well. I'm going to pause. I went ahead and took 1.63 radians and converted that into degrees by multiplying 1.63 by 180 degrees over pi. That turned out to be 93 degrees. You know, 93 degrees is really close to the y-axis in the second quadrant. So as a vector, this is just barely into that second quadrant. So when we took 29.52 times the cosine of 93, that gave us this really little x number right here in this right triangle, the negative 1.9. And then this large side of the right triangle is the 29.47. When we took the 29.52 times the sine of 93, it gave us 29.47. So this side was almost the length of this side being very small. So I know I'm correct because it was at a 93 degree angle. I just want to ask you to pause and think like that sometimes. Finally, the intensity of a signal from a radar microwave signal is given as follows in volts per meter. Write this in exponential form. So what I want to do is I want to take that negative 65.3 degrees and I want to convert it to radians. So I could just leave it as a negative number and multiply it by pi over 180. And I would get a negative 1.14. Remember, that's rads. In exponential form, I just take the r value, 37.0, and then e to the negative 1.14 j power. Again, I could have made this a coterminal angle. I could have made it positive, so that would have been, it looks like 5.14 j. So I could have written it as e to the 5.14 j power 37. All right, so I'm just going to write it like that. Very good. When we go into our next section, we're going to look at multiplying, dividing, raising to a power, and taking roots of complex numbers. But they're all going to be based on complex numbers in this exponential form because, as you see up here, complex numbers in exponential form behave like algebra problems, and very simple algebra problems. Even this one way up here, 2x to the 3rd power cubed. So we're going to study raising to a power, multiplying, dividing, but they are best done in exponential form and then convert or think about the process in polar form.